Cosmont Design Group is an Australian-based company, integrating architectural design, urban planning, landscape design, interior design, and architectural construction supervision. It has completed many outstanding projects successfully over the course of its 35-year history in Australia, China, and other countries. One of the founders of Cosmont, world-famous architect Mr. Yang Yunaishinjero, engineered many innovations in architectural design and technology. He designed works such as the Beijing Library, the second largest library in the world, the 40-column structure of the Bandaranaike Memorial International Conference Hall in Colombo, Sri Lanka, and the award-winning Islamabad Sports City in Pakistan, which used a mere 4 columns to support the vast span of the entire building, a revolutionary approach at the time. In the 1980s, Mr. Yang Yunaishinjero and his son, B. Daishinjero, joined forces with Australian architect Harry Hammore to establish Cosmont Modular Design Group in Sydney. The group's notable projects include designs for the Beach Plaza Shopping Centre in New York, the China Garden Hotel in Bangkok, Thailand, and participation in the design and supervision of the Sea Life Sydney Aquarium and Wildlife Sydney Zoo, alongside numerous residential projects. In the present day, Cosmont Design Group continues on the path of developing an architectural style that merges Eastern and Western cultures for the Australian market. Their portfolio encompasses commercial, civil, and industrial buildings, all of which showcase their imaginative and innovative approach to architectural design. Their attention to human scale and functional considerations is evident in their ability to integrate each building seamlessly into its environment. Mr. B. Daishinjero, the director of Cosmont, has won many design competition awards, such as the China Theatre Design Competition, later published in the Chinese Architectural Journal, and the Best Preliminary Design for the Nantong Olympic Sports Center, which in 2004 was published by China Literature Publishing as one of the best architectural designs of that year. Concurrently, he held leadership and collaborative roles in several commercial and civil construction undertakings in New Zealand and Australia. These included the conceptualization of a hotel development zone in northern Queensland, as well as numerous civil residential designs. Cosmont Modular Design Group also took part in the designs for the Sydney 2000 Olympic Games Aquatic Centre, as well as designs for some projects for the ABC. Cosmont Design Group is also well versed in the area of construction management. The Fuzhou Yuanhong City project, comprising a commercial, office, and residential building complex of approximately 400,000 square meters, was funded by Salim Group, administered and partially supervised by Cosmont, and erected by the French SAE Engineering Company. Cosmont additionally designed some interior shop layouts for the project. Cosmont Modular Design Group also designed and oversaw the building of several New South Wales government-funded swimming pools, the Volkswagen headquarters in Sydney, and one of the members also site supervised the interior construction of the Hilton Hotel. Thus, Cosmont is skilled not only in Chinese design and construction, but also in Western architectural practices and project management. In the early 1990s, BEAD began to incorporate the architectural design of the combined modular system in response to the construction industry's needs and to expedite the construction period, with the intention of replacing traditional construction methods. BEAD's concepts were based on modular furniture design in his student days, revolving around the concept of using a sole base module to achieve infinite and flexible combinations. In 2011, a collaboration between a New South Wales-based developer and Cosmont led to the construction of a 12-story residential building which employed modular design for its hundreds of kitchens and bathrooms, resulting in a significant reduction in construction time. In order to make modular buildings economically competitive, international cooperation is necessary. China, with its comprehensive production and processing capabilities, is uniquely positioned to swiftly produce modular building systems. This advantage, coupled with the complementary strengths of other nations, can result in excellent outcomes when China serves as a processing base. Whilst modular design has been around in the Australian industry for several decades, it is only recently that excitement around the potential to mass manufacture buildings, and in particular homes, has increased. Largely as the country's population has steadily grown, as the housing market has begun to bite, as the build-to-rent market has risen, and as the construction sector begins to feel the effects of a severe skills shortage. In this video and on our website, we provide a glimpse of Cosmont's architectural designs through pictures of our works, showcasing our expertise. This proposed design for 240 Elizabeth Street in Surrey Hills, Sydney, not only incorporates a modular system for the office building, but also integrates an automated car park system. This system can accommodate 80 vehicles within a narrow vertical space of 10 floors, integrated within the office building itself. This design is not only cost-saving, but avoids disrupting the complex system of underground pipelines, and addresses the challenges of parking in the bustling city centre where finding a parking spot can be difficult. Having driven their car to a designated space, the driver applies the brake and exits the car. The driver taps a card, and the driver can then depart whilst the vehicle will be automatically lifted and precisely delivered to the parking spot allocated by the computer. When collecting a car, it is possible to do so by swiping the card reader at any gate, with a waiting time not exceeding 70 seconds. The vehicle conveying system will then lift and transport the car accurately from its stored parking space to the designated gate. This eliminates the need for the driver to remember or search for the car, thus saving time. Here is an illustrative example demonstrating how it works. The auto car parking system can be configured in a circular, rectangular, or square shape, and can be applied to both above ground and underground car parking. Modular construction is a term used to describe when elements of a building, or even the building itself, may be prefabricated off-site, and then transported and assembled in the desired location. Traditional construction methods instead involve bringing raw materials to the site for processing, combination and assembly via competent tradespeople. The aim of modular construction is to increase the degree of prefabrication off-site, including framing, cladding, fittings, and finishes, and reduce on-site building activities, minimizing the chances of rework on-site. The optimum mix and degree of these objectives varies from project to project. Where this concept is maximized to deliver structurally complete building units to site, it is described as volumetric or three-dimensional modular construction. Other forms employing a lesser degree of completeness, but which may be efficient options, are variously described as flat pack, or panelized elements, or prefabricated components. Modular construction concepts are not solely limited to residential building works. Any method where on-site work is minimized and prefabrication is maximized is considered modular construction. Presented here is a modular office complex, showcasing the process from design to completion, from construction in the factory to installation on-site. A proposed residential development on the Central Coast utilizes a modular building system to construct a 200 square meter house, using a total of 7 modules to complete the task within a single day. Completion of 24 dwellings can be accomplished in a very short time frame. Here we see the same method used in a project in Chatswood, Sydney. The modular system can also provide granny flats for the demanding Australian market. Cosmodular's unique autolock system allows modules to be used either to construct permanent buildings, or to be installed as temporary structures. The modules can be added or removed according to functional requirements. In relation to hospitals, for example, those built using the Cosmodular system can provide the full range of services during normal times, but during times of high demand when a quick response is required, additional modules can be added to fulfill specific needs, such as isolation units, operating theaters, clinics or wards. When no longer required, these modules can be removed and used elsewhere. A cost-saving measure that not only saves environmental resources, but also saves time, as the modules are already constructed and ready to use. The modular office complex is showcased here, from its design and construction to its shipping and final installation at the site. Here it is used to provide a holiday resource in Tasmania. Cosmont Design Group and China Construction Shenzhen Decoration Company have formed a joint venture to manufacture and provide modular building products. The prefabricated modular building version 2 system is a low-carbon, eco-friendly, intelligent, steel-framed modular construction product. Our team employs an innovative design concept that leverages BIM technology to plan the function and overall design of the building. This approach effectively overcomes the area limitations of the module and extends the indoor and outdoor architectural space through innovative design. What will the architecture of the future look like? Through a combination of green building and adaptable, prefabricated design, we will bring architecture back to its origin and serve the living experience. Our team will continue to explore the application and practice of prefabricated buildings, promote intelligent digital integration in the design process, and seek to create a healthy, safe, intelligent and comfortable world. Cosmont Design Group in association with CADG was one of the first companies to establish its presence in the global building construction market, following China's open door policy. It has a staff of over 2,100, including 2 academicians of the Chinese Academy of Engineering, 5 national design masters, 61 experts who receive government subsidies, around 400 nationally registered professionals, and over 600 senior designers and researchers. More than 92% of the staff are technical professionals. Cosmont plus CADG's extensive business scope covers project consultation, management and supervision, urban and town planning, design and construction, environmental and energy-saving assessments, building intelligence consultation, traditional architecture, interior and landscape design, historical cultural heritage conservation planning and consultation, and research works concerning housing industry technologies, building material and equipment, and BIM technology research. Cosmont plus CADG has overseen or accomplished a series of noteworthy national-level programs and projects focused on scientific advancement and technological research. Since 1986, Cosmont plus CADG has been awarded over 160 scientific research prizes, ranging from national to provincial and ministerial levels. Additionally, they have contributed to over 70 national and local standards and codes, and undertaken over 1,000 5-year plan projects. Cosmont plus CADG have further established a project-oriented managing system, resulting in multiple design project departments and studios headed by prominent individuals. Additionally, we have established a series of sub-organizations, such as the Architectural History Research Institute, the Design Verification and Consultation Institute, the Intelligent Engineering Center, the International Design Consultation Institute, the Residential Architecture Department, the Human Environment Department, the United Architecture Design and Research Center, the BIM Design and Research Center, and the Green Design and Research Center. Our team has successfully navigated technical challenges and partnered with expert consultants and industry organizations to develop innovative prefabricated modules. This approach ensures that building spaces can be customized to meet client needs more effectively. Our modules rely on industry-leading ultra-high precision assembly technology and a vertical cone socket positioning system to support their 4 beams and 8 columns, while ensuring accuracy control within 2 mm. Our method improves construction site and project management efficiency and accuracy, because all stages of production, processing, and assembly take place in the factory. The largest single box is 12 meters long, 2.6 meters wide, 3.3 meters high, and weighs 15 tons. The installation accuracy can achieve millimeter precision. The assembly and hoisting of all modules can be realized within 2 days. The accuracy can be controlled within plus or minus 2 millimeters, and 95% of the building can be assembled in the factory, which greatly reduces the risk of outdoor aerial work for workers. Additionally, revolutionary changes in structural connectors extend the integrity of indoor and outdoor buildings and improve efficiency in installation. The modules can also be reused, which greatly reduces the waste of natural resources, and can also provide swift, assembled buildings in the case of emergency. As an additional development, a joint venture has been formed to produce a modular system made of stainless steel, enabling the building of 10 stories in 1 day. Here, economies of scale can be achieved through production lines that embrace automation and use standardized elements. By having teams focused on producing specific aspects for building components repeatedly under the same conditions, productivity can be increased, and quality can be substantially improved, reducing the number of defects in the completed building. There is also the benefit of reducing time spent on sites, where the costs of providing temporary power, accommodation and facilities can quickly add up, and where the potential for disruption is higher. While some of these time and cost savings are, of course, offset or occasionally even cancelled out by other elements of the process, the benefits of moving away from the site environment are still compelling. Quite aside from the advantages in delivery, off-site approaches appear to provide attractive solutions to a number of the challenges currently facing our wider society. These techniques could allow for housing to be delivered more rapidly in high-density urban areas, helping to tackle the housing crises currently facing many developed nations, such as Australia. They could also enable the fast construction of infrastructure projects, enabling new and emerging communities to grow. An underlying contributor to the housing crisis currently facing Australia is a lack of skilled operatives entering the construction workforce. Off-site approaches could help address that, by reducing the demand for labor capable of constructing homes with traditional methods. The extent to which work can be taken away from construction sites varies significantly. At one end of the spectrum, volumetric solutions create entire closed spaces in a factory and then deliver those to site for installation or assembly with other similar elements. Some buildings may incorporate a degree of volumetric construction in the form of bathroom pods or plant spaces. Conversely, non-volumetric systems are large elements of a building or structure that are prefabricated before being brought to site. Panelized systems such as cross-laminated timber or structurally insulated panel systems fall into this category, as do unitized facades and large stainless steel elements. Finally, component-based approaches take the concept to a far more granular level, effectively creating a kit of parts and drawing on a series of predetermined items that can be produced, delivered to site, installed, operated and maintained with ease. Cosmont plus Kaji's commitment lies in upholding the joint company's values of client loyalty, contribution to society, and environmental innovation, whilst adhering to its guiding principle of scientific management, dedicated services, meticulous design, and exceptional quality. Of late, Cosmont plus CADG have been successful in securing an increasing number of foreign aid projects, and it continues to foster innovation-driven growth in this area. Now and in the future, by utilizing its comprehensive advantages in design, research, human resources and technology, Cosmont plus CADG will actively broaden its market and collaborate with national and international partners to provide highly efficient and top-quality services to all clients. Thank you for listening to our presentation. Please feel free to contact us for further details.